Hello everyone, welcome to Learn Programming with UDay. Today in this video, we will discuss about stack data structure and different operations we can perform on stack ADT. So without any further delay, let us get started. Stack is a linear data structure that stores data in a continuous fashion. Because stack is a linear data structure, the word continuous means the data values will get stored in a sequential fashion. And stack follows a strategy called LIFO or FILO. The word LIFO or FILO mean last in first out or first in last out. The meaning of this can be understood by considering this simple example. Let us consider we have a stack data structure, and presently the stack data structure is completely empty. Now let me insert a value called 20 in it, and now let me insert one more value called 20, and let me insert one another value which is 30. So as you can see in the iterations here, we have 10 value in the stack which is inserted in the first, and then we have 20 which got inserted second, and we have 30 which got inserted third. Now if I'd like to make delete operation here, the first most element which gets deleted is 30, because 30 is the topmost element in the stack. So any operation in the stack can be performed only from one end of the stack, which is top side. So as you can see here, we have 10, 20 and 30. The most recently inserted element is 30. So that's the element which is going to be deleted first. So which tells that the last inserted element, which is 30, gets deleted first. So last in first out is the strategy which is followed by the stack ADT. If I keep going like this, 20 gets deleted and then 10 gets deleted. You can see that we have inserted 10 first, and the last most element which gets deleted is 10. The first most element which we insert will be the last deleting element. Vice versa, the last inserted element will be the first deleting element from the stack. Coming to the terminology of stack, we have different terminologies in stack. Like first we start with top. So top is a pointer that is connected to the topmost index of the stack. What I mean by that is, so we consider this stack, we have 10, 20 and 30. So top is a pointer which is connected to the topmost value 30. So here we consider the index numbering for every single memory location in the stack. For example, we have 10 with index 0 and 20 with index 1 and 30 index with 2. So now you can see that top variable always connects to the topmost element, which is 30 in this case. And any operation in this stack can be performed only using top variable, and the initial value of top will be -1 because the index numbering starts at 0 in the array, and we use array for implementing the stack ADT or stack data structure. Similarly, we have other terminology called overflow. The word overflow means it tells that the stack is completely full and the maximum capacity has been filled already, and there is no any vacant place to insert any other value inside stack. Similarly, we have underflow state where we tell that the stack is completely empty. So in order to perform any insertion operation into stack, or if I'd like to insert any new value into the stack, I should be able to check whether the stack is overflow or not, because it makes sense that when the stack is completely full, we won't be able to insert any other value. And similarly, when we would like to delete any value from the stack, first we should check whether the stack is empty or not. In this word, the underflow states the stack is completely empty. Hope you are clear with terminology of stack. Let us move ahead with the operations that which we can perform on this stack. On stack we can perform different operations, and important operations on them are push operation, which also mean inserting a value into the stack, and pop operation tells that we can delete any value from the stack. Similarly, we have display and peek operation and count operation. These are all the operations which we can perform on the stack data structure. Now coming to the push operation, we will see how the push operation works. Push operation, we can insert a value into the stack. Any new number can be inserted into stack using push operation. We will see different steps we follow when we try to push or insert a new value into the stack. In the first step, we check for the overflow state of the stack. That means we should first check or make sure that the stack is not full to insert a value. If in case the stack is overflow state, then we won't be able to insert any number into the stack. And we check the overflow state of the stack using this condition, which is top greater than or is equals to max minus 1. Here max is a constant which holds the maximum number of elements we can store in a stack. For example, take 5 is the maximum value, then in the stack we will be able to store only 5 numbers, where the index number starts from 0. So it goes on like 0, 1, 2, 3 and 4. Now 4 will be the maximum index number for inserting a value into the stack. And coming to the second step, in case the stack is not overflow, then we will be able to insert a value into the stack. And we do that by incrementing the top variable first and then assigning new value into the top position of the stack. So using these two steps, we'll be able to insert a new value into the stack. Now let us see the steps pictorially. First, consider we have this stack where you can see that we have 5 values filled already, and if I try to insert one more number 60, I won't be able to do the same because here the condition is getting failed. That is, top value is presently 4 and we are comparing that with 4 greater than or equals to max minus 1. Here the maximum capacity, let us consider 5. So 5 minus 1 is 4. So here 4 greater than or is equals to 4 condition gets satisfied. Then we just print to the user telling that the stack is overflow. We won't be able to insert any other value. Let us consider a stack which is having free locations now. Here you can see that we have inserted 3 values already and we have 2 vacant places. Now I will be able to insert a value. So what I do is first I increment the top position, which is I have changed the top position from second index to third index by incrementing it by 1. And now I will be able to store new value 40 into the third index or third position of the stack, which is 40. So these are the steps to insert or push a value into the stack. Hope you understood push operation. Now let us see how pop operation work. Pop operation is used to delete a value from the stack which are existing in the stack. Here we also follow certain steps, and here as I said already, first we check for the underflow state of the stack. The word underflow means empty. If the stack is empty, we won't be able to delete any number from the stack, which makes sense already. So we check the underflow state of the stack using this if condition. If top equals to -1, then we tell that the stack is underflow. That means the stack is completely empty and we won't be able to delete any number from the stack. If this condition fails, then we will be able to delete a number from the stack. We do that by first printing which number is getting deleted, and then we simply decrement the top pointer. So we will try and see this and understand this pictorially. Let us consider this stack. You can see that the stack is completely empty and there are no any values in the stack, which also gives us that top variable is presently holding -1. So if top equals to -1, then we tell that the stack is completely empty. Let us consider a different situation where we have certain values in the stack. You can see that we have 4 numbers in the stack already, and the top pointer or top variable is pointing to index 3. We will be able to pop or delete a number from this stack, and I can do that first by printing 40 is getting deleted first. So I print on the display saying deleted value is 40, and all I do is simply decrement the top pointer by 1. So here I have decremented the top pointer from 3 to 2. So now that means logically 40 has got deleted from the stack. Hope you understood pop operation and the steps that we follow in deleting any value from the stack. Let us move on to the next operation, display operation. In display operation is used to display all the existing values in the stack, and we here display values from top to bottom. That means the most recently inserted value will display first, and then it follows the previous, and then it follows the previous, and it goes to the 0th index of the stack. We do that using 2 steps. First, we check for the underflow state of the stack. the word underflow mean empty. Obviously, we cannot display any values from the stack if the stack is in the underflow state. We check the underflow state by checking top equals to -1. If top equals to -1, then we tell that the stack is empty or it is under underflow state. If this condition fails, then we start a for loop. Using for loop, we will print all the numbers from top to bottom. Here I have initialized I variable to top, and I am repeating this for loop till I reach the 0th index of the stack, and I decrement the I variable from top to 0. I keep repeating this loop until and unless I reach I equals to 0. All I simply do is I just access ith position of the stack and I display the corresponding value. I keep repeating these steps till I reach I equals to 0. Let us pictorially represent them. Let us consider the first situation where the stack is completely empty, and you can see the top value is -1. Now we just simply tell that the stack is underflow state and there is no values to display in the stack. Let us consider one more situation here. We have 4 values in the stack and we are able to print them on the screen. We do that by first pointing top to the I variable. Here you can see that the top is connected to the topmost value, which is 3. So I becomes 3 now, and firstly I display 40 on the display on the screen, and then I decrement I variable to 2, and then I display 30, and then I decrement I variable to 1, and then I display 20, and then I decrement I value to 0, and then I display value 10. So till I reach from third index to 0th index, I keep repeating the for loop, access every single value of I from the stack and display them on the monitor. So using these 2 steps, we will be able to display all the values which are stored in the stack. Hope you understood display operation. Let us continue to the next operation, which is peek operation. The word peek means the topmost element which is available in the stack. It can also be said as the recently inserted value into the stack. So peek operation is used to display the topmost value present in the stack. We do this using 2 steps. First, we check for the underflow state of the stack. We do check the underflow state using this if condition top equals to -1. If top equals to -1, then we tell that the stack is completely underflow, or it is completely empty and there is no any topmost value in this stack. If this condition fails, then we go to the second step, and here we just simply print stack of top is the topmost value, because top is the variable which is connected to the topmost value of the stack. Let us say this pictorially. Here I have considered an empty stack where we don't have any values in the stack. Now we just simply display the stack is underflow state. Let us consider this state. Here you can see that we have 4 values in the stack and the topmost index is 3, and now all I do is I just display stack of top, which is stack of 3, which is 40. So using this operation, we will be able to display the topmost value of the stack. And let us see how the count operation work. Count operation displays number of values available in the stack, and we achieve this in 2 steps. First, we check for the underflow state. Underflow mean empty of the stack, and in empty state we won't be able to display the number of values in the stack. All we display is stack is underflow. If this condition fails, that is then we do the second step. All we do is we just simply print top plus 1 values are available in the stack. The reason why I have taken top plus 1, because the index number starts from 0, so I have to print top plus 1 values are in the stack. Let us see that pictorially. Let us consider this stack where the stack is completely empty. All we display is stack is underflow. Let us consider this stack where we have 4 values in it, and here you can see that top value is 3. But you can see that there are 4 values in the stack called 10, 20, 30 and 40. Because of this reason, I have printed top plus 1 values are available in the stack. So these are all the steps which we follow to do the count operation on the stack. Hope you are clear with the count operation as well. So this is it for this video, guys. So hope you understood what stack is and different terminologies that are there in the stack, and what kind of operations can be performed on stack, and how every operation can be achieved in steps. In the next video, we will try and implement the stack program in C, and we will try and execute the same. So in the next video, we will try executing stack program using arrays. Hope you like this video, and if you like the content of this video, please do like the video and also comment down if you have any doubts or if you want me to cover any topics in C programming and data structures. And if you would like to watch further content of my channel, please do subscribe to the channel. Until then, thank you so much. Have a wonderful day ahead.